Our last example, same issue. This time we want red first, blue second, and the order matters. Okay, so again, two marbles drawn at random. What's the probability that first is red, second is blue? And they gave us two ways of doing it. First one is with replacement. So if I do A, I'm looking for probability of the first one being red, second one being blue. And again, probability is all about how many things are there and how many ways are there to make what I want. Right? So I can see how many marbles? How many marbles are there? 11. Very good. 4 red, 7 blue makes 11 marbles total. Our first pick, we want to pick a red marble. So our chance of picking a red marble is 4 out of 11.
Times.
The rule says to replace, right? So I got a red marble. I picked it out. It's right there. It's red. I can see it. It's right there, my fingers. It's a very tiny red marble, but it's right there if you look really closely. All right. And I put it back in. All right. So now, the second pick, how many marbles are there?
7. I mean, there's 11.
There's 11 marbles, of which 7 are blue, right? So my second pick, I want to get a blue marble. So again, I replace, so the same number of marbles is there, the same number of blue marbles is there, which was 7. And notice nothing reduces, right?
Yeah.
So the probability of getting red than blue with replacement is 28 on top over 121. For part B, without replacement, now I don't want to replace, probability of getting red on the first pick and blue on the second pick. So the first situation is exactly what it was. We have 11 marbles, 4 of which are red. So my probability of getting red on the first pick is still 4 out of 11. And I pull it out, I see it's red, and I set it on the table. Now my urn has 10 marbles in it, of which 7 are blue. And notice 4 and 10 happen to divide. On these without replacement, or with replacement problems, they quite often reduce. I'm not going to say they always reduce, but quite often they do. So, 2 over 11, 7 over 5, so that makes a total of 14 over 55. Do we think that's more or less than the other one?
More.
Seems like it should be more, right? Because by taking a red marble out, the chance of getting a blue on the second pick should increase a little bit, right? Because now there's more blue marbles compared to how many marbles there are. So if we take a look again, if we just want to verify that, 28 divided by 121, that was our first one. And 14 divided by 55 is our second one. 25% as opposed to 23%. So it is a little bit better. So it's not always, one's always bigger than the other. It depends on how you're picking. The chances of getting the second pick, whether it's a better or worse chance of the second pick, basically. So that's with replacement, without replacement. They're going to throw them at both at you. So sometimes they'll ask both, sometimes they'll ask one or the other. So be paying attention to those words. Once you start seeing two things happening, especially picking marbles out of an urn, that's the way they like to do this most often. Make sure you have replacement rules in place. Are we putting it back in? Are we keeping it out? That makes a difference as far as what the probability is going to be.